Greetings and welcome back. I haven't finished editing yet, so I think this is part 3, but I wanted to finish this off. And unfortunately, well, let's say I've got some good news and some bad news. Let me first put a battery in here and hope that this actually has enough of a charge to come up. Now, what you should see when you bring it up is 10-10-0, which is a confirmation that it's actually functioning. But there was a flaw in the circuit board. That's the bad news. The good news is I've figured it out. And I want to do a quick hack on this because there's something I don't like. But let's just sort of jump in real quick. Once you've got all the components together and you've got a battery or you've got a power source, it should power up and you should get something close to that. The problem, the flaw, actually has to do with this character here, this digit here. It is not lighting up, or it was not lighting up until I figured out what the problem was. And this is where the art of the bodge comes in. And this is going to be a little hard. Let me see if I can actually zoom and bring that in. And I'll show you, there is a little wire right here that goes from here to here. The flaw in the circuit board, and so this will not be your fault if you assemble everything and you do not have that 6th digit. Basically the problem is that there's no trace going to this particular connection right here, and that is one of the transistors that turns on this digit. So if that transistor does not have power, it cannot switch the power. That is the problem. So after studying the circuit diagram for a bit, I realized that what I could do is hook a wire from here to here to provide the power that it needs. I'm going to try and take a better picture of this and put it in there so you have a good reference of where it goes. I should say that the wire that you're looking at here is not a copper wire. It looks like a copper wire. The problem with the copper wire is if you're not careful, running across this other connection right here, you would make contact, you would short it out. That would short out that particular transistor, which I forget which digit that controls. But what I did was I used magnet wire, which is a specialized kind of thing. So if you're going to do this, you're actually going to need a wire with some insulation on it to make sure it doesn't short out anything else. But once you make the connection from here to here, that digit should turn on and you should get 10-10-0 and it should start counting like that. I will dive into the switches a little later, but the other thing I want to do, I don't like this battery pack, and because I put in the rechargeables, I have what should be 7.2 volts, which is well above the 5 volts that everything is running on, but it drains down really quickly, and it may just be my batteries are not very good. I'm not going to blame it on the circuit, but I did notice that after it runs for about an hour, hour and a half, this transistor right here, actually not a transistor, this is actually the voltage regulator that we put in early on in the construction. That gets hot. It should not be getting that hot. There should probably be a resistor in the circuit somewhere to drop the voltage somewhat before it gets to that point. Otherwise, the difference between the voltage you're putting in and the voltage that you're supposed to get out, the 5 volts that it wants, that gets consumed or dissipated as heat. And so that's why this is heating up so much. And that's why what I want to do is provide this with a 5-volt supply. And that's going to go back to a hack video that I haven't released yet. So I'm going to try and get that one out before this whole series. And that is a hack for a very simple USB device, which is a breakout board, which will take a USB mini connector, much like I had to go digging and I found a bunch of cables. If you have an old phone or an old device, save the cables, maybe even save the power adapter, where did I put that? Oh yeah, right here. One of these wall warts that has a USB connection. And so this basically then provides me with wall power converted down to the 5 volts for the USB, which goes into this, which can then plug into this, if I get it in the right orientation. And then I can tap off of 2 of the wires here, and there's more detail in that hack video. I can tap off of these 2 wires, and I can connect them in here. I thought about actually bypassing all the regulation circuitry and just using the regulation of this, but it's simpler just to wire it in that way. So I'm going to go ahead and wire this up, and we'll be right back. And we're back. I've now assembled the hack, which is a micro USB breakout board. I'll put links to the board and to the wire that I used. They're also in the hack video that will come out soon enough. Just so you have a place where you can go find them either on eBay or Amazon. I'll provide all those links. No point in dwelling on how I put it together. So what this does for us now is it gives us the ability to hook up a cable, and I'm going to use this particular one. I'm going to hook in first on that side. The reason being that I want to use, actually let me get my other, I need to demonstrate one little problem that has nothing to do with the project itself. But I like to test with a power bank first, because if something goes wrong, I only lose the power bank. If I were to plug this into my computer and I'd screwed something up and it shorted out, I could damage my computer. I don't want to do that. So a simple USB power bank or a wall plug like that is a better option to start with until you know you've got it right. So if I plug this in, what you should see is 10, 10, 0. And there we go. But in a moment, you're going to discover that there is a problem with this particular power bank. It's actually a feature, but in this application, it's a problem. Here we go. 3, 4. There it goes. It shut itself off. The power draw for this clock is so low that the power bank thinks there's nothing actually hooked up, so it just shuts itself off. The solution to that is a different power bank. So sorry if your power bank does that to you. That's, I mean, it's still a good power bank, but it's not a good thing for this project. Ultimately, in the end, there's one other problem with this project, is that there's no battery backup at all. So if you unplug the clock, like if you unplug a clock that's plugged into the wall, you're going to have to, when you plug it back in, reset the time. That's an unfortunate thing, but that is reality with this particular project. So I'm going to plug this into a different power bank now, and this should last beyond that 16 seconds that we just saw. Meanwhile, I'll tell you that I'm going to give you the instructions for, here we go, 14, 15, 16, boom, it didn't turn off. I'm going to give you the instructions for how to set the clock and the alarm and briefly go over some of the other functions. I haven't completely explored them yet, but I'm going to give you sort of the rationale for how you can discover it. So let me move that out of the way for a second. Let me bring in my mat where I've written things down for convenience. And let me try and slide this down a little bit so you can see both. So let's get the clock back in the picture. Good, okay. Now, if you think in Chinese, where this was made, then having your switches laid out from right to left makes more sense. S1, S2, S3. Their functionality is going right to left. S1 is the function select button, S2 is the function expansion button. This is their terminology or how it got translated by Google. And S3 is number low plus 1. There are multiple functions to each of these. The basics are that with the S1, if you press it, each time you press it, it selects a different function. Either you're setting the time, you're setting the alarm. The third one, it'll be a countdown timer. The fourth one, it'll be a stopwatch. And the fifth one is just a counter where you literally press a button and it keeps adding 1. So these are things that you can do with a clock. And so they just built all of this functionality in. But what you're probably most interested in is the time and the alarm. And so for that, if I hit this one time, it will start to blink. So I'm going to go ahead and set the time, but you should also know that this particular clock, and I will probably put an edit at the beginning of the first episode so you know this right off the bat, but it's a 24-hour clock, not a 12-hour clock. What I mean by that is a 12-hour clock would have an AM and a PM, and it only goes 1 to 12 and then 1 to 12 again. 24-hour clock goes 1 to 12 and then 13 to 23. Sometimes it's referred to as military time. But so I'm going to set this for something beyond noon. I'm going to go for 1:57, which will make more sense in just a minute. If I hit the S1, I'm increasing the hour, or sorry, the S2. So I'm going to go to 13, and then I'm going to try to go to 57 by hitting the S3 button. Now you can basically keep rapidly hitting it, but be careful when you get towards the your target. In this case, I'm shooting for 57. If I go too fast, I might roll past it. It will roll over, and then you're going to have to hit it that many more times to get back again. There is no backward function. So there's 1357. Now, if I want to get out of this blinking mode, I just hit S1 enough times to get back to a solid display. So that would be really function 2, function 3, function 4, function 5. Then we're back to the clock. So now you can see it's holding 1357, and it'll continue to hold it. If I want to go to the alarm, I'm going to hit S1 twice. That'll give me the alarm. Now, it's very similar to the time. If I hit S3, it'll increment the hour. Basically, S3 lines up at the hour, S2 lines up with the minute, and there is no ability to set the seconds. So if I push this, oop, I am wrong. There we go. That's interesting. I hadn't noticed that. That's backwards. I apologize. So S2 increments the hour and S3 increments the minute. So if I go past 23, I get all lines. All lines means that the alarm is turned off. So be aware of this when you go to set up your clock, that if you don't go into the alarm function to turn that off, then at 10:10 at night, 10:10 p.m., your alarm will go off. It will only go off for 3 seconds. That's another quirk of this particular design. Your alarm only lasts for 3 seconds. But I'm going to go ahead and set this for a little bit further. So I'm going to increase the hour. And let's see if I can do this. I'm going to go for 14. I'm going to roll back around to 1400 so that I can have the alarm go off and you can hear it. Let's hope I've done this quickly enough. We'll find out when I go back to the clock. Yep, in about 30 seconds it's going to go off. Now I'll also point out this is your alarm buzzer, and I still have the piece of the sticker on top of it. You can pull that off, it'll be significantly louder, but I'm going to leave it as is because I don't want to be too disturbing. So we'll just wait for another 10 or so seconds, and if I'm right, the alarm will sound. Okay, hopefully the microphone picked that up. It went off for about 3 seconds. Now, that is the alarm done. I'm going to end up unplugging this and plugging it in somewhere else so I can watch it and make sure everything stays functional. The reason I did the hack with the power is because I had the battery pack, and even with the batteries fully charged, it would only last like an hour and a half, 2 hours. I think it was my batteries rather than the circuit. It's not drawing that much power, but it was useless. I couldn't use it as a clock if the batteries are going to die and it's going to shut off. So I need this hack so that I can ultimately plug a cable in and get one of these wall warts and plug it into the wall. Then, unless we actually turn the power out to the house, I'll have a continuously running clock. Moving on to the countdown. Let's see if I can actually do the countdown here. 1, 2, 3. And then, yeah. I couldn't quite figure out. It's got to be some combination of S2 and S3. If you hit S2, it keeps adding to these digits. So now you got 2 digits. I think if you hit S3, oh yeah, okay, S3 is increasing that. Let's see if I go to S2. Maybe I need to go to S1. No. Yeah, S1 just put me into the stopwatch at this point. So I'm guessing S2 or S3 is going to be the start, and one of them is going to be a stop or a pause. So there we go. Now we got the stopwatch running, and I can stop it, and I can start it again. So S2 is start and stop. S3 does nothing. So it doesn't have multiple timers. And I'm going to guess that if I pause, let's see. Okay, it's a reset. Once you've stopped or paused, depending on how you look at it, S3 is your reset. So that explains the stopwatch. That leaves us with the counter, which, if I remember right, yep, basically just hitting S2 will just keep incrementing. So if you are monitoring something and you need to have a count, you can keep pressing the button and you'll have a count. S3 resets it. So that's the setting of this thing in a nutshell, plus the actual hack for the power, plus the hack or bodge on the back because they screwed up when they made the circuit board. I'm going to notify the seller that there's actually a defect in the circuit board and maybe point them towards these videos so they have some kind of reference to give people should somebody complain about it not working when they finished building it. Hopefully you found this and you found it useful. Thank you so much for watching. Take care. See you on the next one.